This video demonstrates DORA, a system that showcases interactive deep reinforcement learning for exploring very large data. Data exploration depends on data and scenario complexities, as well as user ability to express their needs. Exploration scenarios range from looking for a needle in a haystack to finding clusters of objects. Several machine learning-based approaches have been developed to learn exploration policies. However, there is a lack of an integrated framework to experiment such policies. DORA the Explorer is an interactive data exploration system that provides users with the full spectrum of exploration modes on large data sets. It is driven by data familiarity and curiosity and opportunistic user interventions. At the heart of DORA are exploration pipelines. A pipeline is a sequence of exploration operators that are closed under a set-based semantics. This is the interface of DORA. In the A zone is the current pipeline that is being executed. In the B zone are the results of the last executed operator in the pipeline. The C zone is dedicated to choosing an exploration mode and selecting the parameters of the model to be trained. The D zone is the operator selection zone, where users may choose from a number of operators and also choose arguments, input sets, execute an operator, or undo a previously executed operator. The E zone is dedicated to pipeline management. Users can save the current pipeline, load the previous pipeline, or restart the exploration. This interface is available to users, whereas they can execute pre-trained pipelines, create new pipelines, or customize existing pipelines. In the offline phase, raw data is pre-processed, attributes are binned, and our set-based data model is instantiated. Additionally, the offline training has two components: a training of an A3C deep reinforcement learning agent that balances curiosity and familiarity, as well as an environment interface that contains training set and encodes the different states of our system. Let's look at DORA in action.
We will start the demonstration with the manual exploration mode. In the manual exploration mode, the user completely controls his exploration session and does not receive any kind of guidance. We have to start the exploration session by a bifacet, which will split the entire dataset on a provided attribute. We will use the magnitude Z. DORA the Explorer currently runs on a subset of the SDSS dataset containing 2.6 million galaxies. We're using 7 exploration attributes. We have selected the color magnitudes, the compacity of the galaxies, and the redshift, indicating how far a galaxy is from the Earth. In the current pipeline area, we can see that we have executed a bifacet. In the current operator results area, we have the item sets resulting from the previous operation. Each line in this area is a different item set. Here we can see that the first item set is 261,000 galaxies big. Each item set is defined by a list of attribute values that are shared between every item of the set. At each step of his exploration session, the user has to decide which sets he will use as inputs for the next operation and the next operator he wants to execute and the attributes of this operator. In this case, we will use this set as inputs and we will split it on the G magnitude. Each resulting set will share the attribute values that are defining the input sets and have a different range of values for the G magnitude that we used as an attribute. The user can also use the partially guided mode. In the partially guided mode, a pre-trained model having a pre-trained exploration policy will suggest the user an input set, an operator, and its attributes. The user in partially guided modes is able to change the input set if he thinks another set is of interest, and even to change the operator to execute. Here we will execute a by superset, which will return the 3 smallest item sets fully containing the input set. At any time, the user can decide to change his exploration strategy by selecting a different model for exploration. For now, the user can only select a different curiosity weights. The curiosity weight represents the ratio between data familiarity and curiosity that was used for the training of a model. The new model will then select different input sets and operator, each model having a different exploration strategy. The user can also decide to use the fully guided mode. In the fully guided mode, the user does not decide anything and everything is controlled by the model. At any time, the user can decide to stop the exploration and to change to another exploration mode or to change the model he uses for guidance. The user can always access some information about the training of a model he uses for guidance and about the pipeline he's executing. The user can always save the current pipeline, load the previously saved pipeline, or restart his exploration.
Stay tuned for upcoming versions.